the things that we do have left to complete, there is one other section with the quadratics that deals with some modeling stuff. Thank you. And we're going to put together the modeling of the quadratics alongside the modeling of the polynomials. We'll do all of that at the same time. It's a lot of stuff that's built that's based off of the calculator. Instead of trying to teach you guys how to use the calculator for one section, and then go into the next unit, and then have to reteach you guys how to use the calculator again for another section, we're just going to combine them and just do them all at the same time. I find that that's going to be a little bit cleaner. So what we've got here is polynomials. A lot of the stuff we're going to do today is all review. You've done this before. You guys just were never really good at it. And it's a lot of little properties that you have to remember how things work. The other thing that we're going to get into going forward is a lot of new stuff. This unit is a lot of newer material. Things that you haven't done before, things you haven't tried, things you haven't seen. So it can be kind of interesting. As far as how far we're going to get this first week, I don't know. Probably get through the first 3 sections without too much of a hassle. 4 sections probably, maybe. The middle groupings of this chapter, it's unit 3, but it's basically all chapter 6 stuff. They're all kind of the same. Once you get the idea of what you're doing in one of the sections, it kind of blends into all 3 of them, or all 4 of them, or all might be the same. So, properties of exponents. And what I like to do with properties of exponents is kind of redefine things that you already knew. For example, what's 2 squared? 4. Okay. What's 2 cubed? 2 to the 4th. 2 to the 5th. And so on and so forth. Okay? Go the other way. What's 2 to the 1st power? It's 2 to the 0 power. 1. Remember that? Anything to the 0 power is always 1. Right? What happens when they start going negative?
That's to the negative 10.
For decimal, you're thinking like scientific notation stuff. Yes, you would move your decimals and stuff around here, but we're not going to do decimals here. Same idea though. Instead of having a decimal, how do we write it then? Fraction. So 2 to the negative 1 means it's not happy where it's at. When you're negative, you're not happy. Do you agree?
Yeah.
A lot of you guys aren't happy right now.
Yes.
Let's see what I did there. You would be happy somewhere else, wouldn't you? Okay. There's no decimals. So this number is not happy in the numerator, is it? Where would it be happy? Therefore, 2 to the negative 2 would be how much? There's no negatives, guys. These are exponents. The values aren't negative.
1/2.
Well, if
1/4. 2. Oh, wait, 2 to the negative 2. I don't understand how you're doing
some of the rules of exponents that you guys have all forgotten. Anything raised to a negative exponent, it's not happy where it is. When it's not happy where it is, it needs to change its spot. X to the negative n is in the numerator. It's not happy there, so it becomes 1 over x to the n. That's how it becomes happy. Likewise, if it's a negative exponent in a denominator, it's not happy there, is it? Where would it be happy? The numerator. Exponent rules. It wasn't happy where it is, so it changes spots. You change its position. You change where it is. You change where it's going to make it happy. Okay? If it was negative in denominator, it goes up top. If it's negative up top, it goes down. Yes?
When you change it, it turns positive?
Nope. What do you mean, change positive? Only thing the exponent value does, yes. Yep. That's all it is. That's all it is. It's no longer negative anymore. It's happy. It moved.
So you'll never have a negative part
God bless you. Sorry, I got cut off by a sneeze. You'll never have a negative what?
quantities and having an exponent.
Not necessarily. Because what's negative 3 cubed? it'd be a negative 27. So you can still wind up with negative values. If I say negative 3 to the negative third power, it'd be negative 1 over 27. Okay? So you can still get negative value, just the exponent just doesn't stay. The exponent stays positive, becomes positive. Okay? Does that make sense?
Yes.
This builds us into a whole bunch of exponent rules that you guys have all forgotten. And what I want to do is take a couple of minutes to go over the rules. Believe it or not, you probably already know most of these. You just forgot them.
So are we having?
Can I just take a picture of that?
Anytime you guys are ready. Great. Okay? I'm sorry, this is a class that I expect you to write stuff. Okay? Because I don't know how the phone's going to help you later on when you want to look, when you have to write out your homework. And granted, I understand your phone is right there, but call me crazy, the more you write stuff out, the better you get at it. You might have heard that once or twice before. What these are basically doing here, guys, are these are all of your rules for your exponents. You guys have all seen this before. I've heard people already complaining, oh my God, I gotta memorize this. You know this, you just forgot that you knew this. What we're looking at here in this example are things called bases and exponents. The base is the A, the exponent is an M or an N, excuse me. If the bases are the same and you're multiplying two things together, you're just adding your exponents. For example, if I had something that was x to the third times x squared, isn't that the exact same thing as writing it out as x times x times x? Isn't that the same thing? How many x's are there? Or you're just adding them together, guys. Same base, different exponents, and you're multiplying, you add them together. Okay? Power to power. When you're raising an exponent to another exponent, you're multiplying it. Okay? Think of it this way. If you've got x to the fourth squared, that means it's that jump twice. X to the fourth times x to the fourth. Which works out to be x to what? 8. So you wind up multiplying your exponents there. This is just a rewritten form of that. Exponent rules tell you all you have to do is just multiply it. Distributing. Same thing you guys have done many, many times. You've got two things in parentheses raised to an exponent. Both of those parts get raised to that exponent. So you have xy cubed. Remember, that just means xy times xy, which is x cubed, y cubed. That's all that means. Okay. That's all that means. Same thing for our negative stuff. It's not happy, changes where it is. We'll talk about that with the twos. Okay. Remember, when things aren't happy, remove them. If it's not happy in the numerator, it's happy in the denominator. If it's not happy in the denominator, it moves to the numerator. That's all that means. All right, that's all that means, guys. Like I said, excuse me. Anything to the 0 power is always 1. And this last one's the one that we'll talk a little bit more about. I don't really like the way that books have always talked about division with exponents. Everybody see how you've got the same base, different exponents, but you're dividing? The way I like to write this out is just a little bit different. The way I like to do this is the following. Who wins in that battle of war? 7 or a 4? 7. Okay, what's 7 minus 4? 3. Okay. Since the 7 was larger, that means it has the most x values, which means it stays in the numerator. Whereas, if it was written the other way, if I write it out as x to the 17th over x to the 40th, now who wins? Where is it going to stay? Denominator. So what's 40 minus 17? See how clean that is to go that way? Instead of doing the subtraction part, because sometimes if you subtract them out, taking the numerator minus the denominator, you're going to wind up with a negative exponent, which means you still have to rewrite it again. If you always write these with positive exponents to start with, and then you break them into that game of war, it's so much quicker and cleaner to solve your solutions, to simplify out. Okay? Does that make sense? I know it's a little bit different than what you guys have probably seen before, but I always like to bring it back to just going with the game of war. Everyone remembers that. And then the last one is, again, just distributing with a exponent to a fraction. You go to both numerator and denominator. Now, what I want to do is take a few minutes and give you guys a few of these to look at. Oops. While I rear them up on the board. Because, no, we're not going to do numbers. I want you to do those real quick. I want you to simplify those out. Okay? And we'll check them in a couple minutes. Okay, I hope you got the first one right. Numbers first. Who wins the battle? 5 or a 3? 5. So it's a 2 over y squared. Quantity 3x squared. 9x squared. Very good. Square them both. Quantity y over 2 cubed. Good. Anytime you get a value, a number raised to an exponent, please write down what that number will equal. Don't just lollygag and write 2 to the 3rd power. I'll figure that out. So then 4 to the 4th power is what? 256. Good. 256 x to the 12th. Good. X to the 0, y to the negative 2. What do you get? Very good. 1 over y squared. X to the 0 is 1. Y to the negative 2 is 1 over y squared. What? When it starts getting to the longer style, remember, take care of your numbers first. Can't simplify 5 and 2. Go to the x's, x squared, y, x to the negative 1. That guy's not happy, is he? Where's he happy? Rewrite it. All I'm doing here, guys, is just taking a second to rewriting the problem with positive exponents. When I do that, then I'm going to start to simplify. I've always found that taking 30 seconds extra to rewrite something, which really isn't 30 seconds, it will lessen the likelihood of me screwing up. Because now in the numerator I get 5x cubed y over 2y cubed. What happens then? What can you simplify? The y's. So what does it become?
5x cubed.
Good. Just taking that brief second to rewrite the positive exponents. Sir.
You can just change x to the negative 1. Wait, no, I want
X to the negative 1. It's already forgotten. Yes, ma'am?
You know, when the two unhappy one?
No, because the only thing that's unhappy is just the x. The 2 would be unhappy if it was like that. Does that make sense? All right, numbers first again. Rewrite everything out. This is just negative 3 over 9. The negative 3 doesn't have a negative exponent, does it? It's just a negative value number. No matter what we do to it, it's never going to be happy unless it meets another negative number. and they have and they have kids, and then they're happy. They have kids then. Sometimes they're okay. I'm going to rewrite everything again with just positive exponents. Okay? Negative 3 over 9 is what? Negative 1/3. Good. X over x cubed. Good. And then y to the 4th. What?
Why to the fifth? Wait. Okay, this is a stupid question. I put, it was the same. I put y to the negative 3rd, because when you do y to the negative 4th plus y, I didn't do that.
What you're thinking about doing here is, if you're following the rule verbatim, if you follow the rule verbatim, you're taking the numerator's exponent, which is 1, subtracting the denominator's exponent. 1 minus negative 4 is 5.
Oh, I did 1.
Yeah.
Plus the
Yes, sir.
It would be the same thing if you put the negative symbol like outside the fraction.
Yes. It's the same thing.
Yeah.
I think we talked about that
Just
before.
making sure.
Yeah, fraction-wise, if it's negative 1 over 3, it's the same thing as 1 over negative 3, which is the same thing as negative 1 over 3.
That's fine.
All three of those are the same. Usually, especially trying to think about what you can use with your calculator, it's usually easier just to put the negative value in the numerator. That's all. I mean, just all three of them mean the same thing. And then lastly, I think we had one just like that. It was 9x squared over 6x to the 5th. So it's 2x to the 3rd. Okay. Hopefully not so bad. Now, what builds out of it is stuff that starts to get a little bit nastier, because that happens a lot. This isn't the one I wanted. Nope, we just did that one. Interesting. Sorry, I hit the wrong file.
It got right, so I have to reprint it. Why is it beating what?
There you go. Get those 4. Start throwing a little bit more negatives at you. Well, a lot of people tend to freak out when they start having all these negative values. So, suggestion I'm going to make is that you overly, I don't want to say simplify, but you want to be extra deliberate in how you write these things out. Take the time to use all the steps so you see exactly where everything's going. 10 to the negative 3rd, x to the negative 9th, y to the negative 15th. Everybody okay with that? All right. Not one of those 3 values are happy, are they? Now they're happy. Everybody agree? Now, 10 to the 3rd power, I believe, is 1,000?
Yep.
And there's my answer. Yes, sir.
First, I just put 1 over that, 10 exit,
And then that's fine. Perfectly fine. Perfectly fine. I like to distribute it because a lot of times you're going to find out that you're going to get negative exponents raised to negative exponents become positive. That way, I can switch it all later. What you did is perfectly fine. There's nothing wrong with it. All right. Here, I'm going to start by rewriting out. Just rewrite with positive exponents prior to doing anything. So it's x, y squared. All I did is just move things around. I made everything positive with the exponents. Y cubed over x squared. Good. Okay. Everybody else okay on that one?
Yes.
You guys okay? You both kind of staring off into this. Is it okay? Okay. All right. I was worried for a second there. You both kind of going, Oh. Ouch. Once again, raising everything out, so you have 4, -2, x to the -4th, y to the -10th. What people screw up when you have a whole bunch of stuff raised to that negative exponent, you're going to change your signs of the exponents, but forget to put it underneath 1. Happens all the time. Okay? And then lastly, numbers first. You get 1/3. X squared over x, who wins?
X squared.
And then y over y to the -1. Okay. Now, people have written this, there's a couple ways you can write it. Just write it as xy squared over 3, 1xy squared over 3. Either way is fine, perfectly fine. Okay? They're all mean the same thing to me. What I want you to do, though, is I've got, I think I've got a couple of, I want to do a couple of tougher ones real quick. Do you mind? You can open it. What's up?
I wonder if we found any calculators lately.
Not.
No one's Inspire with the 84 basically.
Nobody's given one to me yet today, but I haven't been down to my mailbox. I haven't seen Tuna, so sometimes Tuna just hands them to me.
Okay.
Did you lose one?
Yeah. I don't know where I lost it though, because I had it Friday, so I put it in my bag. I went to grab it today, and it just wasn't there.
No, I haven't seen. I haven't had one yet today. Sorry.
Come up here to ask you.
Yeah, I'll go run down there and see if I can find one. No problem. Let's try one more, then I'm going to give you some tricky ones. I mean, stop.
You're gonna give us all one
I'm hard only.
I'm not. No, it's hard. It's hurting.
It hurts if you drop your pencil on your toe, I think. I've heard worse excuses. You just have to know how to use it, that's all it is.
You don't understand how to cite.
Going through this one, rewrite with your numbers right off the bat. -7 over 3 times 21. All I'm doing is just rewrite it. In the numerator, I have x, y to the 10th. You okay with that? I'm also going to bring up that y squared and then bring down the x to the 5th. All I've done there is just rewrite everything with positive exponents, just shortcutting things through. What's that?
Is that decimal?
No, 3 times 21.
Oh, look at that. You said no decimals.
So now, simplify out. So we get -1 over 9. Y to the 12th. X to the 4th.
Yes.
Okay. Now, could you have written it as negative y to the 12th?
Yes.
It's fine. It's not a big deal. You didn't have to. It's fine if you did, because it's still going to work itself out. It'll still work itself out. All right. So here's what we're going to do. I have 9 of these on here. What I want you to do, well, obviously, is the 9 of them. When we come in tomorrow, I'm going to have you guys enter in your answers into the clickers and we'll check them. So tomorrow when we come in, I will give you guys, you know what, I might as well do it now. I'll give you guys your ID numbers. That way you can write them down and have them ready to go. Okay?
So easy.